Namaskara. So, in this video, we are deriving an expression for capacitance of a parallel plate capacitor. Okay, on the parallel plate capacitor, we are calculating its capacitance. Capacitance is how much it can hold the energy. That's now capacitance. So, now in order to calculate that, in order to derive that, okay, we'll first assume few basics which we learned from the previous topics. Okay, first basic ಏನಪ್ಪಾ ಅಂದ್ರೆ electric field E is equal to, we know that, minus dV by dr, where V is the potential, R is the distance, or it can, in general, it can also be written as V divided by length, okay, dimensionally. And next, electric field due to a charged thin plate is given by sigma by 2 epsilon naught, which is actually independent of the distance. Okay, it is independent of the distance. So, electric field is independent of the distance. Yavade point al tagondru kuda sigma by 2 epsilon naught bartade. Sigma is nothing but charge by area, surface area of the plate. Next, capacitance C is equal to Q divided by V, charge by potential. Okay. So, in order to analyze this, we'll assume a parallel plate capacitor. Okay, eradu plates. Two plates whose surface area ಬಂದು A, ಇವುಗಳ surface area ಬಂದ್ಬಿಟ್ಟು ಎಷ್ಟಿದೆ ನನಗೆ, they are A, and these two are separated by a distance D. Okay, these two are separated by a distance D, and ಇದರ ಮೇಲೆ, okay, we have a positive charge plate 1 ಮೇಲೆ, it means it is having plus sigma, and idhar mele we have negative charge, which is nothing but minus sigma surface charge density ida. Okay, these are the basics. Okay, this is figure construction. Iga now ಏನು calculate ಮಾಡಬೇಕು actually, what is the capacitance ಎಷ್ಟಿದೆ ಅಂತ ಬೇಕು. Capacitance is generally given by C is equal to Q by V. So Q can be identified by sigma is equal to Q by A, and ನನಗೆ next ಬೇಕಾಗಿದ್ದೇನು V, potential ಬೇಕು. Potential can be done using, and identified or calculated using electric field. So, in order to find the electric field, we'll choose the three regions: region number 1, region 2, and region 3. Region 1 alli navu ಏನು ಮಾಡಬೇಕೀಗ, okay, we have to place plus 1 coulomb ಬಿಡ್ತಿದ್ದೀವಿ. So, ಇಲ್ಲಿ plus 1 coulomb ಬಿಟ್ಟಾಗ, because of the positive charge, okay, ಇಲ್ಲಿ positive charge ಇರೋದ್ರಿಂದ, ಇದು positive ಆಗಿರೋದ್ರಿಂದ, because of this it is repelled, E plus, and idu negative plate irodrinda it will be attracted, E minus. See, electric field due to a charged plate is independent of the distance. Yavade point allidru idurdu electric field eradu kuda magnitude, because sigma magnitudely same idava, adrinda eradu same irtada. Both are having same magnitudes but opposite in direction. Therefore, net electric field in this region 1 is equal to 0. Similarly, if you check at the center, illi now check madadaga, because of this it is attracted towards this is E minus, and because of this it is repelled in this direction, E plus. So, the electric field at the between the region, between the two plates is E2. ಈಗ ಇದು E2 ಇದ್ದಾಗ ನನಗೆ ಏನಾಗಿದೆ, E2 is equal to electric field due to plate 1 plus electric field due to plate 2, that is minus E. Plate 1 ಬಂದು ನನಗೆ ಎಷ್ಟಿದೆ, sigma divided by 2 epsilon naught, plus plate 2 ಕೂಡ ನನಗೆ sigma divided by 2 epsilon naught. So, net electric field ಇಲ್ಲಿ existence ಆಯಿತು, that is equal to sigma divided by epsilon naught ಬಂತು. ಈಗ ಹೊರಗಡೆ ಥರ್ಡ್ ರೀಜನಲ್ಲೂ ನಾವು ನೋಡಿದಾಗ ಸೇಮ್ ಕೇಸ್, because of the negative charges it will attract, and because of the positive charge plate it will repel. So, ಇಲ್ಲಿ ಕೂಡ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, in this region also the electric field is 0. Therefore, from this we can clearly say that the electric field exists only between the two plates. Outside the regions, the electric field is 0. Therefore, ಈಗ ನಾವು ಇದನ್ನು ನೋಡ್ಕೊಂತ ಹೋದ್ರೆ electric field ಬಂದಿದೆ, the electric field between the two plates is E is equal to sigma by epsilon naught. But we know that sigma is equal to Q by A. If the charge is Q divided by A into epsilon naught. And we know that electric field is potential divided by V. If we are connecting this to a potential of V, ಯಾವುದೋ ಒಂದು potential V connect ಮಾಡಿದ್ರೆ, then we can write this as V divided by separation distance ಬಂದು D is equal to Q divided by A epsilon naught. Therefore, from this we can say that Q divided by V is equal to A epsilon naught divided by D. But Q by V is nothing but capacitance C. Therefore, capacitance to store the electrostatic energy by this capacitor C is given by A epsilon naught divided by D. A epsilon naught divided by D. So, this represents the energy capacitance of a capacitor to store the electrostatic energy. It is actually C is independent of Q and V. Q gu ಮತ್ತು V gu C gu ಸಂಬಂಧ ಇಲ್ಲ. C ಅನ್ನೋದೇನಂದ್ರೆ ಇಸ್ ಅ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಸಿಕಲ್ ಪ್ಯಾರಾಮೀಟರ್. ಇದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಿಸಿಕಲ್ ಪ್ಯಾರಾಮೀಟರ್. ಅದರ ಕೆಪಾಸಿಟಿ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಬೇಕು ನಾವು. So it generally depends on C directly proportional to area of the plates. As the area of the plates ಜಾಸ್ತಿ ಆದಂಗೆ surface charge density ಜಾಸ್ತಿ ಆಗ್ತದೆ. Area of the plates ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. C is inversely proportional to the distance. Distance between the plates ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. And C is proportional to dielectrics. ಇದು ಹೆಂಗಪ್ಪ ನೋಡಿದ್ರೆ if the plates between the two capacitors ಎರಡು ಕೆಪಾಸಿಟರ್ಗಳ ನಡುವೆ if we are filling with some kind of dielectric instead of air is also a dielectric, but air ಬದಲು ಬೇರೆ ಯಾವುದಾದ್ರೂ ಒಂದು dielectric which is having greater than 1 ಇದ್ದರೆ epsilon r ನ ಫಿಲ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ನಾವೇನು ಬರಿಬೋದು C prime is equal to epsilon naught epsilon r A by D. Okay, so ಯಾಕಂದರೆ we know that epsilon is equal to epsilon naught into epsilon r. So ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು we'll write this one, and so the capacitance of the capacitor basically depends on area of the plates, distance between the plates, and dielectric medium between the plates. If dielectric medium and area of the plates are more, the capacitance is more. If the distance is less, the capacitance will be less. Very important, 3 or 5 mark question I hope you understood this. Thank you.